All right, greetings all of you that had to miss today's lesson. I thought I would just record this and hopefully get everybody up to speed. What we're going to be doing is graphing secant and cosecant functions, and it's going to be a lot more user-friendly than tangent and cotangent. If you know how to graph sine and cosine, you know how to graph secant and cosecant. So, having said that, let's jump in. Just keep in mind that, cosecant as a function is the reciprocal of sine. So that's going to create some issues, especially where sine theta equals 0. So we'll get rid of all that messy stuff. All right, so the first thing they're telling us or asking us to do is to sketch a dotted sine curve in this interval from negative 2 pi to 2 pi. All right, so let's go for it. So make your horizontal axis kind of long so that we can fit in two. That doesn't look good. Let's see. It should look better, actually. So that we can fit in two periods. And remember that if we're graphing just y equals sine theta, then the period is going to be 2 pi. All right? So this is x, this is y, and we'll just start out at 2 pi and work backwards like we always do. This is pi, this is pi over 2, this is 3 pi over 2, and it'll take us all the way down to 0. And then we can just kind of make a mark out here, maybe perhaps a little further out, maybe like right here. We'll call that negative 2 pi, and then halfway back will be negative pi, and then negative pi over 2 here, and negative 3 pi over 2. And of course, for just your basic parent for sine, it doesn't go any higher than 1, and it doesn't go any lower than negative 1. Okay, so remember how sine graphs? It graphs low, high, mid, high, mid, low, mid. So let's get a little bit of color change. All right, so we'll have an anchor point right here, and an anchor point here, and here, and here, and here, and so on. Just going to keep alternating like this. All right, and so there's the anchor point for 2 cycles. All right, so now we're just going to complete the graphs, but we're going to do it with a dotted line because we're actually not here to graph a sine curve, although this is going to be part of the process. We're here to graph cosecant. All right, so that's just going to form like a foundation, sort of like a backbone, whatever you want to call it. And now they're asking us, where does sine theta equal 0? Well, it's going to equal it on any of these anchor points. It's on the x-axis. And that's a sorry looking x. Let's get that a little better. Okay. So it's going to be 0 at negative 2 pi, negative pi, at 0, at pi, and at 2 pi. And they want us to draw asymptotes where sine theta equals 0. And that's because when sine theta is equal to 0, cosecant theta is going to be undefined. So there's no way we can get any y values for x values that are not defined. So let's go ahead and put in these vertical asymptotes, and they're going to go right through where x is 0, well, where y is 0 on the x-axis, let's put it that way. And so we've got one there, we've got one here, and we've got one here on the x-axis. And we have another one here at negative pi. Whoops, almost missed that one. And we have one at negative 2 pi. All right, so that is not yet a cosecant curve, but it's going to make it so it's impossible to mess it up. So then we're at number 4 here, and it says in between the asymptotes draw solid curves going in the opposite direction to the sine curve, but tangent to the sine curve where sine theta is equal to positive and negative 1. All right, so let's go with this color here, and they're asking us to draw in, okay, that's one branch of a secant curve. Here's another one, and the two that I just drew, this one I'm drawing and the one before it, make up a period, one up, one down. So here comes the second period, like so. And that is our cosecant graph right there in that kind of yellowish color. So it's going to be tangent at this point because that's where sine theta equals cosecant theta. Because when sine theta equals 1, you just flip that over to cosecant and it's still 1. And here at negative 1, when sine theta equals negative 1, well, if you get the reciprocal of that, it's also negative 1. So here, 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 here are where sine theta and cosine theta are equal to each other. All right? So then the domain, that's going to be tricky, and we're only responsible for this. This is the parent function. So it's going to be all real numbers, but x may not equal, let's see, n times pi, where n is an element of the set of integers. And if you look really closely and think about that, that is the same domain as cotangent. So if you know cotangent, you can apply it to cosecant. Now the range for cosecant is, well, it's negative infinity up to here, and then there's this big empty space. And then it picks back up at 1 and keeps going. So this will be negative infinity up to negative 1, and we include the negative 1, right? And then that'll be connected with 1 to infinity, and we will include the 1. Okay? So there it is. Pretty easy stuff. If you can graph a sine curve, you can graph a cosecant curve. Now, I'm just going to go ahead and pause for a second because I have to change papers. So hang on. All right, hopefully we're recording again. Let's go ahead and do the same for secant, and now they want us to draw a dotted cosine curve in the interval from negative 2 pi to pi. All right, I can do that too. So let's get a nice straight line here, give it a little distance. That'll be our x-axis. Maybe this time put some arrows on it just for fun. And here is the y-axis. Now this is supposed to draw straight. And finally it is. All right, so we'll put some arrows on it. And we can go from 1 down to negative 1. And again, remember the period here is, since it's the parent, will be just 2 pi. So we'll mark off 2 pi here. And we'll mark off negative 2 pi here. In the middle will be 0. So halfway to 0 here is pi. I mean, we've done this like a billion times, right? All right, so then here halfway back is negative pi, and this is negative pi over 2, and this is negative 3 pi over 2. Sorry, that's kind of running together. Okay, so now we're good to go, and we're going to go ahead and graph the cosine, but we're only going to do this dotted, right? So let's put in some anchor points. Remember, it's high, middle, low, middle, high. And we can go the same in reverse. Middle, low, middle, high. And let's just dot that as a cosine graph. We're not actually graphing cosine. We're actually going to be graphing secant. But it has a backbone of cosine. So there it is, easy to graph. We've done it before. And the next step is to go ahead, oh, well, let's just see, where does cosine theta equal 0? Well, it appears to be at negative, let's go ahead and go back to blue here. Negative 3 pi over 2 and negative pi over 2 and positive pi over 2 and positive 3 pi over 2. And it says draw asymptotes where cosine theta equals 0. And it's going to be for the same reason. It's just secant theta is undefined where cosine theta equals 0, because the reciprocal of 0 is undefined. So let's get that green back, and that means we're going to put a vertical asymptote right here, and one right here, and one right here. Sorry, I never get the scaling quite perfect, but hey, other than that, I'm a complete Rembrandt. All right? Okay, and then in between them, we're going to draw curves, just kind of like we did with cosecant. All right, so here's a curve, and here's a curve. But this is supposed to be, here's another one. This is actually supposed to be 2 periods of this. So we have this and this, but then we have this without a match in the upper, all right? So what we're going to do is we're just going to complete with half curves. Since we kind of arbitrarily stopped, now let's count them. 1, 2, 3, 3.5, 4. All right, it takes 2 branches. There's actually 4, even though we cut one up. So divided by 2 is 2 branches per period. So that is complete. And so we did that. We made it tangent to that cosine curve that we drew dotted. And that's where we have cosine is equal to 1 and down here at negative 1. And the reason that we do that is because, again, let's go back to blue here. It didn't turn blue. Hang on, let's get rid of that. All right, now we'll go to blue. It's where cosine theta equals secant theta. Easy peasy, because if cosine theta equals 1, the reciprocal for secant is 1 also. And when cosine theta equals negative 1, then the reciprocal of negative 1 is also negative 1, which is the value for secant. So that is where the two are equal. So the domain of secant is going to be a little different than it was for cosecant. It looks like it's hitting in the pi over 2 increments. So it is the set of real numbers, but x may not equal pi over 2 plus n pi. That should be a pi. Where n is the element of the set of integers. All right? And if you think about that, isn't that the exact same thing as what it was for tangent? Okay? So if you remember tangent, you can remember secant. And the range for this has a big break. It's like everything that cosine isn't, except for the points they share. So that's negative infinity to negative 1. And that'll be union that with 1 to infinity. And so that is your secant. Hopefully that's just as easy as cosecant was. So we're going to pause again, and I'm going to open the third page, which magically is here. All right. So what we're going to do now is just use that kind of scaffolding or the skeleton approach that we've been using to just apply the transformations. So here it looks like we've got a period change because of the b value. So the period is going to be 2 pi over b. So we're back to that rather than pi over b. So 2 pi over 2 is going to give us a period of pi. And it does also look like we have got a horizontal shift pi units to the right. So horizontal shift right pi. All right. So what I'm going to do now, this is secant. Normally this would go from 0 to 2 pi, but we do have that horizontal compression, so we're just going to write this from 0 to pi, and that'll put pi over 2 in the middle, and pi over 4 in between there, and then 3 pi over 4 right there. So this is after the horizontal compression. And then we're going to go, since we're shifting to the right pi, we're going to set up a whole new set of anchor points. We're going to add pi to each of those values. So 0 plus pi is pi. Pi over 4 plus 4 pi over 4 is 5 pi over 4. And this will be 2 pi over 4 plus 4 pi over 4 is 6 pi over 4, which is 3 pi over 2. And what you're seeing is this is going from 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then finally 8 pi over 4, which is 2 pi. So this is what we're going to label our x-axis with. All right, so let's get this going. And let's see here. That's not good. We will get this straight. What is that doing? How weird. Okay. All right, now I'm not getting any ink flow. All right, hold on. I am going to pause for a second and work out the issues. Just a minute. All right, apparently I had fallen off the color for some reason, so let's try this again. All right. Yikes, it's still doing that. Why are you doing that? Let's try this. All right, that's better. And I'm still not kind of satisfied with that. Sorry to... Now it's drawing straight. Not quite there. We'll get there. All right, we're going to live with that not straight so that I don't put you to sleep. All right, so let's go all the way out to, we'll go out to 2 pi to the right. All right, so here's 2 pi. And we'll come back halfway to pi. And we're only going to fill in here. So this will be the middle value here, 3 pi over 2. And then 5 pi over 4. And 7 pi over 4 is right here. Now you can actually put in the 4 anchor points and do a whole nother period right between 0 and pi, but nah, let's not do that. Secant, remember, is set up with a foundation of cosine, so there is no stretching or shifting vertically. So we'll just do from -1 to 1. And remember that if we're doing the cosine underpinning for this, it's going to be high, middle, low, middle, high. And we're going to put in vertical asymptotes wherever we're on the x-axis, which one will be right here. And we'll have another one right here. And let's put in the backbone for this, so I'm just going to change colors. All right, not perfect, but good enough. And when we go to draw this in, we will have one full branch right here in the 3 pi over 2 region, and we'll have a half branch right here and another half branch right here. So that makes a full branch and then a second. 2 branches make a period. This is done. That's it. All right, again, you can draw another period in here, or you could draw another period out here, but we typically only graph one single period. All right, this will be the tough one. If you can understand this one, and this will be pretty much gold. So the first thing we're going to have to do is factor out the 4. So f of x, oh, I like the green, I think I'll keep it, equals cosecant, and we'll factor out the 4. That'll leave x plus, all right, think. This has to, if we remultiply it, go back to 3 pi over 4. So how about if we make it 3 pi over 16 plus 2? All right, so that's going to create some transformations. So we'll just write out the period. The period is going to be a is 4, right? So that'll be 2 pi over 4, which is pi over 2. So that'll be the period for us. It looks like we are going to have a vertical shift, and that'll be up 2. And it looks like we have a horizontal shift, and that'll be left 3 pi over 16. Okay, so let's go ahead and just figure out what we would have for our anchor points if we have no shifting at all. So that would start us out after we do our horizontal compression, 0 to pi over 2, halfway back is pi over 4, halfway back again is pi over 8, and then in between these two numbers, pi over 8, 2 pi over 8, and 3 pi over 8 will complete that. So there's the 5 anchor points, and then finally 4 pi over 8. So this is going to be your horizontal compression values. All right, and now since we're going left, right, 3 pi over 16, we want to subtract from each of those values 3 pi over 16. All right, 0 minus 3 pi over 16 is negative 3 pi over 16. Pi over 8 is the same as 2 pi over 16 minus 3 pi over 16 is negative pi over 16. All right? And then, let's see, so we're adding, let's see, 2 pi over 16 from here to here. We're just going to keep doing that. So the next one will be pi over 16, 3 pi over 16, and 5 pi over 16. And that will set up what we need to label on our x-axis for one period. All right, so let's see if I can get this thing to draw right. Okay, that'll be good enough. And that'll be good enough. That's a bad looking arrow up there. Okay, so let's put down some marker values. First of all, we can go up 1, 2, and then finally 3 because of the vertical shift. And what I'm going to do here is I'm going to draw a translated x-axis. Remember, this is x and this is y. So here is the translated x-axis. Now I am not going to label that as though it was a midline because it's not a midline. That's only for sine and cosine, but it'll help us to get the graphing part right. So let's go to negative 3 pi over 16, and then here will be negative pi over, whoops, 16. Ugh, that looks terrible. I can't live with that. Go away. Oh, it came back. There we go. All right, so over 16, and this will be positive pi over 16. And then the next one here was 3 pi over 16. And then finally 5 pi over 16. Okay, good. So we can put in some anchor points. And remember, these are going to be anchored 2 up normally from where they might be because of the vertical shift. It is based on sine, right? So your middle, high, middle, low, middle, and high. Let's see. Middle, high, middle, low, middle, high. What am I forgetting here? Middle, high, middle, low. Hold on. I'm going to pause again. All right, dummy me. I put a mark here. It should be over here. All right. The scaling is a little messed up here, so we'll just have to live with it. All right, and so that'll complete it. Yeah, that was weird. All right, so we'll put in, yeah, see, that's a little bit far right there, but we'll deal with it. All right. So there it is, translated up, shifted over to the left. And we're going to treat anything on this translated axis as 0, all right, which will give us vertical asymptotes. So we'll have a vertical asymptote right here. And we'll have one right here. That's a little far away. So we'll put that one and get rid of it. We'll put that one right here. Of course, you should be using a ruler. When I'm doing this electronically, I can't make a ruler work on it. But that's good enough. And then we can put the branches in. So one up here and one down here. And there you go. That's it. All right, so you know, hopefully if you have any problem with this, you can just replay it, watch the video again, pause it, you know, kind of internalize, and well, you know how to do this. So I'm going to sign off, and hopefully I will see you soon.